Hey everybody. Let's see. So the plan for this video is to just go through some law of sines problems. So, I have one problem written here, but I guess just as a reminder, the law of sines, what does the law of sines say? The law of sines says that in any triangle at all, so that's kind of like the beauty of the law of sines is we're no longer restricted to just working with right triangles. It's all triangles now. This relation holds. The sine of A over A equals the sine of B over B equals the sine of C over C. And kind of depending on your book, it might be written this way or it might be written as the reciprocals. A over sine of A. So A over sine of A equals B over sine of B equals C over sine of C. These are both the exact same thing. They're both the law of sines. All right, so let's see if we can use that fact to prove or to solve this problem. This problem, we're given a triangle, ABC. We have two angles of ABC. We have one side length, and we were asked to find the exact side length of A, the precise side length of A. So not using a calculator at all, we should be able to find a precise side length. Let's see here. So, well, I've got angle A. I've got side A. I've got side C. If I had angle C, then I could use the fact that sine of A over A equals sine of C over C. Or maybe even the better one actually might be to use this second version because it's just slightly easier to solve for A. It's the exact same thing, like you could go through the motions of solving this thing for A. But notice that in either case, the key is that I need angle C. Well, lucky for us, we already have angle A and angle B, so angle C is kind of implied because the internal sum of angles for a triangle is 180 degrees. So angle A and angle B are together, what, 135 degrees, which means that C is 180 degrees minus 135 degrees, which is 45 degrees. Cool. All right, so we can fill that in. And now we have all of the pieces that we need to solve for side A. So let's see, I'll just rearrange this thing, or rather rearrange like this one so that I just have it in terms of side A. So rearranging this, just multiply through by sine of A. We get that A is equal to C times the sine of A over the sine of C. And yeah, now we've got all of the pieces. We can just fill things in because side C is root 2 times the sine of A, which is 60 degrees, over the sine of C, which is 45 degrees. All right. So what does that end up coming out to? Sine of 60 degrees. Well, what's that? Root 3 over 2, yeah? Yep. Root 3 over 2. Divided by the sine of 45 degrees, which is root 2 over 2. Working this thing through, well, this root 2 gets pushed into the top. So it's going to end up being, I'm going to do kind of two steps in one here, root 6 over 2. It will be all of that divided by root 2 over 2, but that's the same as multiplying by 2 over root 2. The 2's cancel, so this would become root 6 over root 2, which is the same as just combining them under the root 6 over 2 root 3. All right? So that should be the solution there. What other problems do we have? Right, we'll just solve a triangle here. We'll solve a few triangles. The first one, we've got angle A is 37 degrees. Angle C is 95 degrees. Side C is 18 meters. All right. And I'm realizing now that I'm going to need a calculator. I don't have my calculator with me. But it's just going to take me 3 seconds. I'll be right back. I got it. And I'm also going to turn off the heat. It's like a cold day today. We went from having like a really nice warm day to now it's all cold. Sorry about that. No, I'm not going to edit that out. I'm much too lazy. All right, let's just solve this thing. So there are rules with law of sines, like you can look up and see, oh, what are we given? Are we given angle, side, angle? Are we given side, angle, side? Are we given side, side, angle? And depending on those, there are different procedures. But also, if you just kind of understand like what's underlying with the various cases and using law of sines, you don't really need to memorize anything at all. All right, so I think it's always a really smart idea to make some kind of a diagram. Let's see, so I've got angle A, which is about 37 degrees. I'll say it's like that. I'll put angle C up here, which means this is side C down here. Oh man, this is an awful picture. So angle C is up here, and angle C is like slightly larger than 90 degrees. So 90 degrees would be like that. It's like this. So we'll come down. My picture is going to make it look very isosceles, and it would be close to being isosceles, I think, because this is 37 degrees. This is 95 degrees. Here's 18 meters. What must angle B be? And by the way, when it comes to these types of problems, when you're asked to solve a triangle, it means find all of the missing pieces. So here we're given angle A, angle C, and side C. I need to find angle B. I need to find side A, and I need to find side B. Well, angle B is nice and easy. 95 and 37 is 125, 132. So this other angle must be 48 degrees. So yeah, kind of close to isosceles. 48 degrees. Side A. All right, so that's over here. Side B. Okay, well, we can kind of make our choice now. We have all of the pieces to just use law of sines to solve for A and B. So we'll start with A. So again, A over sine of A, so the sine of 37 degrees, equals, I have to use C and sine C because I don't have side B yet. So it equals 18 meters over the sine of 95 degrees, which means A is equal to 18 times the sine of 37 degrees divided by sine of 95 degrees. And what does that come out to? It's going to be nothing pretty. If you're plugging this into your calculator, make sure that you are in degrees mode, or you're going to get the wrong answer. It comes out to about 10.8740, and that's meters. So that's side A, 10.874 meters. All right, and then sine of B, or finding B, would be really similar. So B over the sine of B, sine of 48 degrees, is equal to 18 over the sine of 95 degrees. So B is 18 times the sine of 48 degrees over the sine of 95 degrees. What does that come out to? Let's see here. So it's the exact same thing as last time. I just need to switch the angle for angle B. 18 times sine of 48 divided by sine 95 is about 13.4277 meters. There. We solved it. Okay? Nice and straightforward. So what case were we given here? Well, we had angle, we had angle, and we had side. So what is that? Angle, angle, side, I guess. Okay. And let's do some more. Let's see. What's the next one? We have, same thing, solve the triangle. B is 38 degrees, 40 minutes. Side A is 19.7 centimeters. And angle C is 91 degrees, also 40 minutes. 91 degrees, 40 minutes, yeah. Okie dokie. Well, first things first, I need to kind of convert these into decimals, because I can't plug, at least with my calculator, I can't plug minutes in, I don't believe. I don't think it's that sophisticated. No biggie. So B is 38 and 40 over 60, so 38 and 2/3. 38.667 degrees is what we'll say. And it's going to be the same thing with C, 91.667 degrees. So it must be the case then that I'm looking for angle A, I'm looking for side B, I'm looking for side C. 38 and 2/3 plus 91 and 2/3. Well, what is that? 38 and 91 is 129. 129 and 4/3. So 130 and a third, right? 130 and 1/3. 180 minus 130 and 1/3 must be 49.667. That's how I'll write it. I better make sure I'm doing my math right. I know that the rounding is going to make it not precise, but so yeah. So I guess maybe since these are given in terms of minutes, it would be 49 degrees, 40 minutes. That would have been another way that I could have done it. Okay. So again, just like a really quick picture, just to make sure that I'm not doing anything silly. A, I'll say this is B, I'll say this is C. Here's 38 degrees, 40 minutes. 91 degrees, 40 minutes. 49 degrees, 40 minutes. Side A is 19.7 centimeters. Okay. So we were given B, A, and C, angle, side, angle. All right, so B is coming from the law of sines, and let's see, I have side A. I have angle A and I have side A, so that's what I'll have to set everything equal to. B is equal to A, 19.7, times the sine of B, sine of 38.667 degrees, over the sine of A, 49.667 degrees. And what does that come out to? 19.7 times the sine of 38.667 divided by the sine of 49.667 is, comes out to about 16.1465, and that would be centimeters. And then lastly, C is going to be 19.7 times the sine of angle C, 91.667, over the sine of 49.667 degrees. And that comes out to, what does that come out to? 91.667. about 25.832 centimeters. There it is. Found it again. Let's see, at some point we're going to run into the ambiguous case, which is the tough one. That's what ends up being tough when it comes to law of sines, is it introduces the so-called ambiguous case. Let's see, which one am I doing next? Oh, I gotta turn the page. Solving the triangles again. Yep, and these should be potentially, some of them are going to result in the ambiguous case. A is 29.7 degrees, side B is 41.5 feet, and side A is 27.2 feet. Okay. So angle, side, side, or we tend to actually call that side-side angle. Right? We would call this side-side angle. Why? Well, because angle side-side is maybe not the most desirable acronym for it. Side-side angle is what we call that. I assume so. Let's see here. Let's draw this thing out. So side A, and again, this might be a case where a triangle doesn't actually exist, so I need to be a little bit precise. At least as much as I can in trying to make this figure. So here's side A. I'm going to put side C up here, or angle C. Here's angle A, here's angle C, which means that this is side C. I don't know how long side C is, so I might do something like this. Just give it kind of like a dotted line. It's a really jagged dotted line. It's a little faint, I guess. I think you can still see it. So A is 29 degrees, about 30 degrees, so we'll say it's like this. Angle B is somewhere over here, so this is side B right here. Side B is 41.5 degrees. Oops, not degrees. That's not right. That side isn't 41.5 degrees. That's strange. It's 41.5 feet. Yeah, surely I didn't drink enough coffee this morning. All right. So something like that, and then side A is 27.2. So it's like, you know, it's more than half of this side. It's like kind of like here. This length is A. But my scale is not, my drawing is not necessarily to scale, so I can't assume, like based off of my drawing, it looks like it might not touch, but I can't assume. How do we check that? Well, we can compare side A. Again, if you just have like the procedures and things like listed out, because there are ways of checking this, like if it's like, oh, angle A is acute and you have that A is less than B or whatever, there are ways of checking it, but most of them will rely on the height. You need to check the height. Here's the height. Maybe I'll just kind of make some kind of indication that here's going to be some angle, some side A. Right, and we need to compare A to the height, because if side A is less than the height, then no triangle is possible, because side A won't actually connect with this bottom piece. So we need to compare them. So we need to find side H. Well, we know that this is 29.7 degrees. We know that the sine of A is equal to opposite over hypotenuse. This would be the hypotenuse of that right triangle. So H is equal to B sine of A, which is 41.5 feet times the sine of 29.7 degrees. And that is roughly 20.562 feet. Yeah, good to go. Because that means that like if we were to hang A sort of straight down here, it would kind of hang like this. So we have a case here where H is less than A and A is less than B. Just to kind of illustrate, this should result in two triangles, two possible triangles. So suppose that this is, you know, this is the length of side A. Just assume that this is the length of side A. I'm going to use my compass to draw a circle of radius A. So, oops, centered at, one side got a little wonky there. So it's a circle, or at least part of a circle, with radius A centered at C. Notice that it touches here at two different spots, right there and right here, which means we have two possible triangles that could be formed. There's like a stray mark in there. Let me erase it. I'm sure it's confusing. There we go. That's how it looks. So there are two possible triangles here. Here's one of them. It's the sort of larger triangle, and the larger triangle means angle B is acute. You might call that B1. The other triangle, the smaller triangle, is where B is obtuse. B2. Okay? So there are two triangles in here. This sort of small one off to the left, and then this larger one that is encompassing everything. Okay? So we need to solve both of them. And I'll call those triangles. There will be triangle A, B1, C1, and triangle A, B2, C2. Because as B changes, C is also going to be forced to change. So it'll be different angles. All right, well, we'll start with angle, well, I guess we'll see which one we're starting with. It's going to fall out and it'll be fairly obvious which one we're starting with because we're going to use the law of sines to solve all of this. Right, so just given what I have angle A, I have side A, and I have side B, which is enough information for me to solve for angle B. So sine B over B equals sine A over A, which means sine of B is equal to B sine A. Hey, there's H over A. All right, well, we just found B sine A. B sine A is 20.562, so I'll just divide 20.562 by A. What does that come out to? 20.562 divided by 27.2 is about, I'm just going to write it here, approximated. It's approximately 0.756. But this is sine B is 0.756. So the angle B is sine inverse of that. Sine inverse of that is, so B is about 49.109 degrees. So, and I've labeled it just as B. We need to decide, is this B1 or is this B2? Well, it's acute, so it must be B1. So this is B1. Angle B1 is 49.109 degrees. And then on top of that, what else do I need? I need angle C1, and then I need side C. Technically side C1, I guess, to be very precise. All right. So C1, angle C1, well, that would be 180 minus 49.109 minus 29.7. Just subtracting the two angles, A1 and B1, from 180 degrees comes out to 101.191 degrees. All right. And let's solve for C1. Well, C1 is going to be equal to A times the sine of angle C1 over the sine of A. So 29.7 times the sine of C1, which we just found, 101.191, over sine of 29.7. Sorry, this should have been 27.2. I was looking at the angle when I wrote down side A. That should be 27.2. Sorry. was like, why is the angle and the side length the same? 27.2 times the sine of 101.191 divided by the sine of 29.7. Comes out to 53.855 feet. 53.855 feet. I'm just kind of like thinking about that really quickly here. Does that make some sense? If this side is 41.5, it's pretty long. And then yeah, 27.2, it does make sense that side C would be around 53 feet. Yeah, that seems about right. Good to go. All right. Well, how do we solve for the second triangle? We need angle B2, we need angle C2, we need side C2. How do we find any of that? The key is noticing that angle B1 and angle B2 are supplementary angles. Why? Take a look at this triangle right in here. So this triangle has side length. This side length is A. This side length is also A. So this thing is isosceles. Isosceles triangles, the angles at their base are the same. So this angle right here, this is B1 on the inside here, which means this angle on the other side, which is the angle that we want, that's B2, this is 180 minus B1. So 180 minus 49.109, 130.891 degrees. Then 180 minus that minus angle A is 19.409 degrees. Or do I feel like I've made a mistake somewhere? My alarm bells are ringing for some reason. I'm going to double check my angle for C1. Okay, that's right. Maybe they are all right, and yeah, I just really haven't had enough coffee. Oh my goodness, maybe that's why. 180 minus second answer minus 29.7, 19.49. Okay, I guess it's right, and I'm just having a weird day. All right. Well, C2 is going to be side A, 27.2, times the sine of C2, 19.409, divided by the sine of A. Oops, sorry, it's off screen. There it is. Oops, jeez. Times the sine of 19.409. Here, I'll show it to you so you can see what I'm doing. You can see all the mistakes that I'm making. Just having one of those days. I don't know what's going on. Divided by the sine of 29.7. What's it come out to? 18. So 18.2433 feet. Those should be the two possible triangles. All right, let's do some more. I got a bunch more that we can do. It's going to be a long video, but who knows? Maybe somewhere, someday, somewhere in the space-time continuum, somebody will come across my videos and they'll be like, "Hey, wow, gee williker, that was helpful." Oops, this is problem 43, but I didn't mean to number it. It's all good. That's what erasers are for. Okay, what else did I have? B is 74.3 degrees. Side A is 859 meters. Good golly, that's a big triangle. B is 783 meters. Cool. So what do we have again? Our old buddy. Angle, side, side. Side, side, angle. Come on. There's kids around. Right. And this time it's given in terms of we have angle B. Previously we were given angle A. So just be kind of careful about that when it comes to sort of determining how many triangles we have. But if you kind of follow this method that I use, you'll be good to go. So here's angle B over here. For me personally, I always prefer whatever angle I'm given, I want to put it in the bottom left. It's just easier for me. And then I can make this angle so 74 degrees, well 90 degrees is obviously perpendicular. 74 is, I don't know, somewhere like 45 would be like right there, so maybe like this. Maybe this is 74 degrees. So 74.3 degrees in there. Again, I'm going to put angle A down here somewhere so that this can be side A. And then side B will be hanging from this hinge, so angle C is like up here. It's kind of written in the problem. Okie dokie. Right. So side B is kind of like hanging. And again, just kind of for like my diagram, this is 859 meters. B is about 100 meters shorter, so it's like right here maybe. This would be sort of like side B, but I can't assume. Can't assume anything based off of my picture. As we say in math, a picture is not a proof. So here's side H again. Same business. We're going to compare side H to side B, see what is possible there. All right, well, H would be, sine of B is H over A. So H is A times sine B. A sine B. So 859 times the sine of 74.3. 859. Here you go again. Times the sine of 74.3 is 826.95 meters. So if what this is saying is that this height right here, this distance, is 826.95 meters. B, though, is shorter. So B kind of like hangs down like right here. Yeah, I was actually very close, I think. This is side B. Notice side B doesn't actually touch. No triangle. No triangle. Why? Since we have that B is less than H and H is less than A. That would be my justification. If you need some kind of justification, that's the reason. Cool. So ambiguous case, we've seen the ambiguous case that results in two triangles. We've seen the ambiguous case that results in one triangle. Let's see if we can get one that that results in no triangles. Maybe we can get one that results in just one triangle. So what's next? A is 142.13 degrees, angle A. Side B is 5.432 feet. Side A is 7.297 feet. I'm doing this on the fly, by the way. I don't have the solution sitting in front of me. It's totally possible that I'm making mistakes. If I have made a mistake and you notice it, leave a comment. Let me know. We can help other people out so that nobody's getting any bad information. All right, side angle once again. So Here's angle A. Oh, this time angle A is obtuse. Fun. Isn't that cool? So 142 degrees, well 135 would be right there, so we'll say this is 142. Over here, somewhere over here is side B, or angle B, so that this is side B. 5.432 feet. And then side A is 7.2. So it would kind of like come down about right, you know, like here. So yeah, it looks like a triangle is going to be formed. Looks pretty certain that a triangle is going to be formed. Let's see, maybe I should give a little bit more justification there for that. I mean, with the obtuse, when you're given an obtuse angle, there are only two possibilities, which is that there is 0 triangles formed, or there's one possible triangle. It's not possible to make, if you're given the obtuse angle in a side-side angle scenario, it's not possible for there to be 2 triangles, because the other triangle would require A to be acute. A is fixed. A doesn't move. A doesn't change. We're given A. We are told A is 142.13 degrees, so that's what it's going to be. It's never going to change. If side A was shorter than side B, then you would end up in a situation where side A never can connect. Since A is longer than side B, though, it does connect. So there's going to be exactly one triangle. So 7.297 feet. Guess I was kind of off about my estimation of where angle B was going to be. It's actually right there. Where'd my eraser go? Hopefully, if you're watching this, you're somebody who feels like either you need a bunch of help with law of sines, and hopefully this is helpful for you, or you're just somebody who, well, you felt like, what the heck, I'm going to watch someone solve some math problems. I hope it's helpful for you. I know this is kind of a strange video, but I thought, you know what the heck, let's make a strange video today. It feels like a strange day. I figured, let's make a strange video. What do I need? I need angle B, I need angle C, I need side C. Well, if I have angle A and side A, so I can use sine A over A or A over sine A, and I have side B, which means I have enough information to solve for angle B. In particular, we would have that the sine of B is equal to B, so 5.432 times the sine of A, sine of 142.13 degrees, divided by side A, 7.297 feet. So let's see here. Let's just do it all in the calculator. We can just do it in kind of one fell swoop here. Just trying to get everything on the frame without the glare. Oh man, if only I had a professional setup. If you happen to have like a very rich uncle, ask them if they might want to send me like some money. That's not right. It needs to be divided by that. Divided by 7.297. Let's make sure that I typed everything in right. 142.13 solid. Come on. 5.432, yeah. So this is the sine of B. Sine of B is 0.45698. We don't want the sine of B, we want B. So I'll do second sine to get sine inverse. Second answer to just pull up the previous answer. What does it give me? 27.1921. That's angle B. 27.1921 degrees. Be careful with your units. I don't personally really care too much because I think in general it's implied. But yeah, I mean, if we had like something where there were different units of measurement, there were degrees, and then there were feet, and then there were inches, and then there were whatever else, miles, yeah, you need to be really careful about your units. But like something like this, like obviously if I'm saying angle B is something, it's, well, I guess there is some ambiguity because it could either be a degree or a radian. So yeah, definitely specify that it's degrees. Some professors though, or some teachers I know, they can really be sticklers about that. And sometimes I feel like their stickler is like just to be, I don't want to say to be petty, but that's kind of how it feels, that like they're just finding reasons, like little reasons to take points off. I had one student one time who was telling me about how she had a professor, like she had an exam, it was a math professor, and her professor, like some of the problems on the exam were you had to, do some explaining. You had to write some things out. And she told me how she had, in her response, she misspelled a word. Not even like a math term, just like just misspelled a word. Teacher doctor points. I thought it was strange, you know what I mean? Like, come on now. I mean, I don't know. I can sort of see it. Math is all about precision, correctness, but also like, can you imagine that? Like doing the math right, having your logic be perfectly sound, perfectly correct, and then, but you misspell a word, and all of a sudden, sorry, I'm like talking and writing at the same time. Your math is perfectly sound, your logic is perfectly sound, you misspell a word and then you lose points. How aggravating, man. Come on. I mean, again, I don't want to say petty, but that's the word that comes to mind. All right, did I do this right while I was talking? Let me know. Looks like it. Yeah, because C would be A times the sine of C. Yep, divided by the sine of A. Let's check it out. 7.297 times the sine of 10.6779 divided by the sine of 142.13. C is this tiny little guy, which makes some sense. This is side C right here. It's a little fella. Comes out to 2.2. Yeah, 2.2025 feet. Just a little guy. Hey, you found it. Exactly one triangle. So in the so-called ambiguous case, when the angle that you're given is obtuse, not too bad. It's when the angle is acute that you gotta do some thinking. All right. Let's do a few more here. What am I at? How long is this video? 45 minutes? Again, I don't know. Maybe someday somebody will come across this and they'll say something like, wow, this answered all of my questions. Who knows? Maybe I'm doing somebody's homework for them. It's possible. All right. Back to angle A being acute. Oh boy. Same thing though. Just started off the same way. So 45 is about right here. 42.5 is about right there. 45 degrees bisects a right angle. That's kind of my reference point there. It's close to 45 degrees. So there's side A. Angle B is going to be somewhere down here. So side B is over here. 8.14 feet. Oh, nice. And now we have a situation where A is larger than B. So if this right here is 8.14 feet, side A is almost twice that length. So it'd be like, just as kind of like, and give you an idea, it's like this, right? This would be about the length of side A. Grab my compass again, see what happens here. Show you what happens. Swing that thing around. It only touches once. It only touches the bottom once, right over here. So that's what the triangle will look like. There's only one possible triangle, and this is it. So we can expect side C to be fairly long. Of course, you can always expect something like that. Okie dokie. Yep. So, what do we need? We need angle B, we need angle C, and we need side C, as usual. Well, what can we get? We have to grab angle B first. We have angle A, we have side A, we have side B. We can use law of sines to find side B, angle B. So in particular, sine of B must be B, so side B, 8.14 times the sine of A, 42.5 degrees, divided by the side length, A. So again, just kind of plugging all of this in. Turn it on first. 8.14 times the sine of 42.5 divided by 15.6 gives us this thing. That's not angle B. That's the sine of angle B. We need the inverse sine of that. Angle B is about 20.6415 degrees. When you're rounding, first of all, as much as possible, save all of the rounding to the end. If you can leave everything precise until the very end, that you know you're getting a pretty decent approximation. Secondly, when you're rounding, always try to round to at least 4 decimals to maintain the precision. Minus 42.5. So angle C must be 116.8585 degrees. Okie dokie. Side C, I'm going to use, you can make your choice. You can equate it with sine B over B, or B over sine B, depending on the variation of law of sines that you're using. I'm just going to use A again. So C over sine C is equal to A, so 15.6 times the sine of angle C, 116.8585, divided by sine of A. That's not right. 8585, 15.6, yep. Divided by sine of 42.5. Surely I've made a mistake on one of these. I'm not checking my answers as I go either. No. 59998. Well, here's a situation where if I want to round it to 4 decimals, it just keeps rounding, so it actually just rounds to 20.6 feet. There we go. All right, what else do we have? What's next? What's next on the hit parade? That's what my great Uncle Norman used to say. He taught me some violin. And we'd go through a piece, we'd play a piece together, and then afterwards, when he was finding what we were going to play next, he'd say, "What's next on the hit parade?" He was a strange guy. I was, honestly, afraid of him before I knew him. He was that kind of a weirdo. He just seemed like a very peculiar person. And I took violin lessons with him, learned a little bit more about him, and started thinking, you know what, he's not that strange. He's actually a pretty cool dude. Alright, so we're given angle B. Same setup. Angle that we're given goes down here. I'm given side C. I want this to be side C right here, which means that angle C is somewhere over here. Angle A is going to be up at the top. So, right, angle B is 72.2 degrees, so maybe about like this. And then this is 145 meters. Okay. So angle B is about half that. Or sorry, side B. Side B is hanging over here, but just kind of comparing it, side B is almost half of this thing, like a little bit more than half. So it's kind of like this. So just based off of my little rough sketch, it looks a lot like no triangle is possible, but let's prove that, because what do we say? You know the old saying, picture is not a proof. In math, maybe in the courtroom it is. Although the word proof in math might be slightly different than proof in the courtroom. You might say a picture in the courtroom is not necessarily proof, maybe evidence. I don't know, maybe it could be proof. I don't know, I didn't study law. All right, let's solve this thing. So I need to find side H, because that's going to tell me if a triangle is even possible at all. So H, sine of B is equal to H over 145. So H is 145 times the sine of 72.2, which is times 145, 138.0588 feet. So yeah, this height right here is 138 meters, I guess, not feet, meters. 138 meters, but side B is less. So relative to H, side B is kind of like this. No triangle. Since side B is less than H and H is less than C. That's the justification. It's not possible. If you want to prove it, you can try to construct these triangles. That's kind of the cool thing about these are real world figures. You could figure these, you could make these in the actual real world, the one that you and I are living in right now. You could check it yourself. No triangle is possible. Maybe if you have some kind of portal into a different dimension, a non-Euclidean dimension, maybe it's possible then. I don't know. Report back. Let me know. All right, 38 degrees and 40 minutes. Well, that's 38 degrees, 38.667 degrees. All right, same thing. This is probably, I guess that's kind of close to 38 degrees. Yeah, I was going to say maybe it's a little bit too large. 38 degrees, 40 minutes. Why do I have a feeling we're going to run into a two triangles situation again? I mean, the alarm bells are going off. They were wrong earlier, but yep. Okay, so put angle B down here so that this can be side B, 11.8 kilometers. Make it just a little bit longer, like that. All right, and then side A is 9.72 kilometers. So it would be like here. I don't know. Is this a case where we might, well, maybe it'll make like exactly one. Maybe it'll be a right triangle. Let's see. The right triangle occurs when this side A is equal to H. H is B sine A, 11.8 times the sine of 38.667 degrees. 11.8 times the sine of 38.667 degrees. H is, looks like there's two possible triangles. 7.3726 kilometers. So yeah, I do believe that there are two possible triangles because we're in a situation where H is less than A is less than B. So yeah, if this thing right here is 7 kilometers, 9 kilometers must be about like right here. So just kind of eyeballing it, be a little bit like this. There's the two triangles. So B1, B2. When I use the law of sines, it's going to give me B1. Another way to think about that is because when we use the law of sines to solve for B1, we're going to have to use the sine inverse. What's the range of the inverse sine? Well, it's negative pi over 2 to positive pi over 2 because we're working with a real figure. Like if it ended up being negative, it just wouldn't make any sense, right? If we said, oh, B1 is, if we calculated it out and it turned out that B1 is like negative 30 degrees, we'd be like, what? That doesn't make any sense at all because negative 30 degrees would be like this coming down here. So that doesn't make any sense. So using the law of sines in these sorts of situations, it's always going to output something between 0 and 90. So, all right, we got two triangles to solve for. A, B1, C1. A, B2, C2. So we need angle B1, we need angle C1, we need side C1. Angle B2, angle C2, side C2. Just setting up where I'm going to put my solutions, that's all. Make it nice and easy for my teacher to find my solutions. Isn't that nice of me? All right. Yeah. So sine of B1 is equal to B, 11.8. This is just the law of sines. If you can't do this in your head, just kind of rewrite the law of sines and then solve for sine of B1. 11.8 times the sine of 38.667 degrees divided by side A, 9.72 kilometers. And I'm just going to do it all. I'm not going to write it all. I'm just going to do it all on my calculator. Why? Well, because I'm lazy. Sine of 38.667. Look, at least I can be honest about it. Most people who are lazy are not honest about it. The thing about being lazy, though, is that you still got to be precise. Oh, right, I can just write it over here. So angle B1 is 49.3316 degrees. Yeah, people love to say, work smarter, not harder. And then they kind of translate that into be lazy about things. Like, what is that anecdote of, who was it, Bill Gates, or was it the Apple guy? What the hell was his name? Steve Jobs, who said he always hires the lazy person because they find fast ways of doing things. And I feel like, yeah, cool. Like, that makes a lot of sense. Except that anybody who has worked with someone who's lazy knows that what actually ends up happening is you just do all their work for them. You know what I'm talking about? You ever been in a group project? And there's just somebody who's just lazy, lazy, lazy. We've all experienced that. If you haven't experienced that, guess what? You might be the lazy one, okay? Don't be the lazy one. Don't make people pick up your slack, man. It's rude. I know that you think that you're being clever. I'm just finding the smarter way of doing things. Well, offloading all of your responsibilities to somebody else isn't the smart way of doing things. It's the jerk way of doing things. Know what I'm talking about? Let's see, so this would be over sine of A. So what's C1 come out to? 9.72 times the sine of 92.0014 divided by the sine of 38.667. Let's see, we're past an hour now. Chances that anybody is watching this, very slim. The only thing that's going to watch this is YouTube's content checker to make sure I'm not doing bad guy things or posting anything inappropriate. And I did write ass earlier, so I don't know, maybe it'll catch me for that. I don't think so. Come on, don't be ridiculous. So we found our first triangle. Let's find the second one. Angle B2 is the supplement of angle B1, so 180 minus 49.3316. This is angle B2, 130.6684 degrees. I don't know, maybe I feel like what's going to end up happening is someday, because I don't get a lot of views on these. I mean, they haven't been up for very long. My videos, I haven't been making them for very long, and I'm not trying to make them to, you know, really do anything except for just sort of help people out. I feel like what's going to happen is someday, maybe a few years down the line, somebody's going to be watching this video and they're going to be like, hey, Ryan, you messed up on one of these problems. And then I'll be like, what? What video are you talking about? I've never made a video in my life. 9.72 times the sine of our new C1. 10.6646. That's probably what I'll say. Say law of sines. What's that? No, come on. I'm not going to forget. Look, I stepped away from math for like a couple of years and then I came back. I love it. I'm an actual addict. Although apparently not so much of an addict that I didn't go and get my doctorate. Oops. So I must not be such an addict compared to some people. I just I got my master's and then I stopped. I said that's probably enough. But I have there's some small part of me that feels like I might end up going back someday to finish it off and grab the doctorate. What would I study? I don't have any idea. At first, when I got into graduate school, when I left undergrad, I thought that I wanted to study topology. Got into a graduate program in California, and I ended up dropping out of it, mostly just because it was like the wrong place, the wrong time for me. That's all. I was at the wrong place in my life. That was it. And I had a really hard time. I had a hard time adjusting out there for a bunch of reasons, and yeah, I ended up dropping out. And I'm from Colorado, by the way, if there's anybody who doesn't know that. Yeah, I had a full ride. Well, almost a full ride. It was a fellowship. I would have only had to pay for, I believe, 1 year, which means that they were going to pay. They were intending to spend like over, about $250,000 on me. Making some math. Went to that program with a dude that I actually was in undergrad with, and it was just purely by chance. It was the craziest thing because the school, UCR, they offered to, once they let me know that they had accepted me to their program, they offered to fly me out so that I could see the campus and stuff. It was the craziest thing, man. I think back on it and I'm like, wow, I can't believe that I dropped out of that. But at the same time, I don't have any regrets. In any case, they flew me out, right? And this, so I'm out in California, walking around this campus that I've literally never seen before. I've never been on this campus at all before. And I know nothing about the campus. Honestly, before they accepted me to the program, because they actually sent me an email. I took the GRE, and then based off of my scores, they sent me an email, and they're like, hey, consider applying here. And I was like, okay, I've never heard of you guys before. UC Riverside, I'd never heard of them. I applied. They accepted me. I flew out there, and while I'm walking around this campus, it was like, it was, the evening. It was probably, I don't know, 5 or so. It was like April of 2015. It was around 5 p.m. or so. I'm walking around this beautiful campus, gorgeous campus. It's like twilight and stuff. The sun is setting. And I'm walking back to my hotel, walking across the campus towards my hotel, and I see this dude walking at me, and I'm thinking to myself, this guy looks exactly like a dude that I knew back in Colorado. I had a couple of classes with him. What did we have together? His name was Ethan. Hi, Ethan. If you watch this, how strange would that be? His name was Ethan. We took topology together in undergrad. We took abstract algebra together. But here's the thing, I'm not a very talkative guy. You might not think that based off of my hour and 10-minute video here. I'm not talkative. I don't talk to people, and especially in school, I get in, I get out, that's it. I didn't ever work with anybody either. One of the biggest mistakes that I probably made was not getting in the habit of working with people. You move faster if you work with people. I didn't. I did all of my undergrad like by myself. I sat alone in a room until late hours and worked and thought. So I didn't know Ethan, but I'm walking through the UCR campus. I see this dude. I'm like, that is crazy. He looks exactly like Ethan. We're walking at each other. He keeps getting closer and closer. The closer I get, I'm like, this is Ethan's doppelganger. I get close enough and I'm like, that is Ethan. I was like, hey man, do I know you? He's like, I think so. I was like, did you go to Metro? Did you go to MSU? He was like, yeah, I did. I was like, bro, what? This is so crazy. Yeah, in any case, I don't know why I'm talking about any of that. I can't remember. I'm just like talking to myself now. Let's solve this thing. This is the last problem I'm gonna do. I'll stop wasting your time. All right, so angle C is 22.8333 degrees. Side B over here, 159 meters. Side C, 132 meters. Looks suspiciously to me like this is gonna create two different triangles. That's my prediction, but let's check it, because the math don't lie, assuming you do it right. So side H here, H is equal to, so sine C is H over 159, so 159 times the sine of 22.8333 degrees. What's that come out to? 61.7 millimeters. So we've got a case where, and this would be, side C. Over here we have a case where H is less than C and C is less than B. Two triangles. So triangle in this time, let's see, I'm still going to list it as an A, B, C, but A is not fixed now, so A1, B1, C, and then also triangle A2, B2, C. So I need angle A1, I need angle B1, and I need side A1, angle A2, angle B2, side A2. Okie dokie. Oh, right, the reason I was talking about UCR is because I ended up dropping out of that program. That was in 2016 that I dropped out of that program. I was only there for about a year. It kicked my butt. My head wasn't really in the game. I dropped out of that and I ended up coming back for my master's at a different school. I went to Emporia State University. Why did I go there? Because they had an online program. So I need to solve for sine B first for B2, B1 rather. So sine of B1 is equal to, so it'd be sine of b1 over b, so b gets moved over here, 159 times the sine of c, 22.8333, divided by 132. So all of that is just to say, be careful, man. You might get bit by the math bug. And that thing don't go away. So yeah, I might go back for the doctorate at some point. Although, I'm not quite sure. I think I've gone about as far in math as I'd like. Like, there are some areas that I just thought were like really, really cool. But I don't know. I'm not quite sure that it's what I want. I think more about going back for like a philosophy degree. I minored in philosophy, and I really liked it. I really liked philosophy of mind. I like thinking. All right, a1, so a1 over sine of a is equal to c over sine of c. Sine of c. Yep. Now I'm blessed to be able to teach math at some local colleges, local community college, local university. I teach at both because I'm adjunct. Let's see, so what did it just give me, and does this make sense? It says A1 is equal to 263.2327 millimeters. And yeah, I think that makes some sense. Yeah. Okay. In general, my other videos, I try to make them a little bit faster. Obviously, this is going to be like my longest math video to date. But I also don't really feel too bad about making a really long video. It's a recording, so I feel like, you know, you can skip through. Find what you need. You don't have to listen to me talk. And you can also just pause the video anywhere that you need it. That's kind of my thought. But I also know that we live in the day and age where people just want their answers now. They want it fast. They don't want to spend more than 9 minutes looking at math. They want to be math geniuses and not have to work for it. Just like how we all want to be Olympians but not actually have to work out. Yeah, it's the same thing, man. Sorry if that was off of the screen there. That's kind of the work that I did. You don't get to be an Olympian without practicing. You don't get to be good at math without putting in the time. Well, most of us don't. All right, that is my law of sines problem set. Let me know if you got any questions. Let me know if you think I made a great big mistake. I probably did.